Okay, g'day folks. I've been asked to explain how we do in exercise 2I of the Year 10 Cambridge 5.3 textbook, how we do question 4 in exercise 2I. It's a little bit more work on fractional indices that we saw in the last video. Remember the law that we came up with for fractional indices. So the law we came up with was that a to the power of m on n was equal to the nth root of a to the power of m. Okay. So the thing about these laws is, and the thing about most things in algebra is that they work in reverse. So if this is equal to that, well then that's true in reverse. That is equal to this. Right? That's what we've written here. The nth root of a to the power of m equals a to the power of m over n. So how does that actually translate into expressions involving numbers and pronumerals? Let's have a look. So if I've got the square root of 5, and when we write square root, we don't write a little 2 there, but it's understood that this symbol means the square root. What number multiplied by itself 2 times will give me this, the square root. Okay. So in other words, there's a 2 in there and there's a power of 1 over here. So the square root of 5 is 5 to the power of 1 over 2, 5 to the power of a half. Okay. The cubed root of 5, well, the cubed root of 5 to the power of 1 is 5 to the power of 1 over 3. Right. Let's keep on extending it. If I've got the square root of 4a cubed, well, remember what I told you when we were looking at surds even back last term, right? We want to see those square numbers. Wherever we see those square numbers, we want to break up our surd. 4 is a square number, so I write my surd as a product. The square root of 4 times the square root of a cubed. Okay. Well, the square root of 4 I can simplify. That's just 2. And then look at this, the square root of a to the power of 3. Well, the square root a to the power of 3, the 2 there means that I've got a 2 in the denominator, the 3 there means I've got a 3 in the numerator. So it ends up being a to the power of 3 on 2. Okay. I'm looking at question H now. So it's got the 8th root of 8m to the power of 4. Okay, well the 8th root of 8 I can't work out, okay, that's going to be something that's well and truly irrational. So that's going to be 8 to the power of 1/8. Oh, hang on, I'll put a step in, sorry, forgive me, I just jumped a step there. So we know that whenever we've got a surd where things are being multiplied, we can break those things up. So it's the 8th root of 8 times m to the 4. So that's the 8th root of 8 times the 8th root of m to the power of 4. Well, the 8th root of 8 I can't do anything with. Okay, so that's just going to be 8 to the power of 1/8. In the same way that this was 5 to the power of 1 over 2, because it's the square root. The 8th root of 8 is 8 to the power of 1 over 8, because it's the 8th root. Now over here, I've got m to the power of 4 on 8. Well, 4 on 8, we know that's a half. So it's 8 to the power of 1/8 times m to the power of a half. That's expressing those terms in index form. Okay. Hope that helps. Please keep on going. It's great to see that you're working. Keep plugging away. I will, when I upload this to Microsoft Streams, I'll have one little exit question that'll be coming up now. And I hope you did okay with that. I look forward to seeing your submissions. Thanks very much, guys.